Hello there everybody. Today I'll be talking to you about polar coordinates. Now this is an interesting field of maths which I will explain now. So in normal coordinates we have x and y, and that's just the coordinates. So if we have the x-axis which is horizontal and the y-axis which is vertical, if we have the point 3, 4, it would be 3 along the x and then 4 upwards on the y, like so. There's really nothing to it, it's really simple. But polar coordinates is a bit more complicated. So if we look back at complex numbers, we had Argan diagrams, and basically the way Argan diagrams work is it tells you the angle that the point is from the origin and how far it is from the origin. And that's the same thing with polar coordinates. Polar coordinates, instead of having the coordinates written out as x, y, they're written out as r, theta, and if you can imagine r as being similar to as being like radius, distance, so r is distance from the origin and theta is the angle from the origin. So let's say we have a point here. Well, we always want to look at the positive x direction as being our point of source, so from here to here that would be 90 degrees, and let's say this is 4 upwards, so the distance would be 4 and the angle would be 90. We use radians in polar coordinates. I think you can use degrees, but I'm just going to use radians. So the polar coordinate here would be 4 and pi by 2. And so it's very straightforward, but we're just going to make things a bit more interesting. So you're probably wondering, how do you go from polar to from normal coordinates to polar coordinates? So there's a special method you can use. So let's say this is a normal set of axes with x and y, and we have the point 3, 4. So 3 along on the x and 4 up on the y. Now to convert these from polar to from normal to polar, we're going to have to find out the distance from the origin to that point. So we can actually draw a triangle here. We want to know what that distance is. Now to do this distance we can use Pythagoras. So we know that the horizontal is 3 long and the vertical is 4 long. So we're going to use Pythagoras to get this length. 3 squared plus 4 squared equals r squared. So r must be 5, just from knowledge. 9 plus 16 is 25, square root of 25 is 5, so we know the distance must be 5. So that's straightforward. So we now know that r is 5, so I'm just going to write it here. Now to get theta, well, if this is a triangle we can use tan. So this is theta. Arctan theta is opposite over adjacent. The opposite is 4, adjacent is 3. So theta equals arctan 4 over 3. And using a calculator in radians, that would give us the answer of, just give me a second, 0.93. 93. So yeah, there's our polar coordinates. We have 5 being r and the theta being 0.93. There we go. Now I'm actually going to formalize this to show you how you can do the whole thing without having to imagine the triangle, which can be a bit of a pain. There's just a simple formula of doing the whole thing. So let's say we have our normal coordinates of x and y. X and y. Now, to get the value of r, we need r is going to be the square root of x squared plus y squared. So r is the magnitude of x and y. The magnitude of r is Pythagoras of x and y. Okay, and then to get x, we need to do x equals r cos theta, and y equals r sine theta. Now you're probably wondering where did these random things come from, but we can in a way derive them. Before we said that arctan of x over y equals theta. Well, let's look at that here. If we do x divided by y, we get x divided by y equals r cos theta over r sine theta, which is, I think I'm over complicating this. It's arctan y over x, I got that wrong. Okay, so if we do y divided by x, we get r sine theta over r cos theta. So that must mean y over x equals r divided by r, which is 1, and sine theta over cos theta, which we know is tan theta from trigonometric identities. And then to get theta, we do arctan y over x. So that's how it works. That's where I got the r cos theta and r sine theta from. But actually, there's a bit more to this equation which I didn't explain. There's actually a plus or minus in front of the r, both r's. This is because for polar coordinates, there's directions. So you can have the positive direction, which is this way, and the negative direction, which is this way. So this is pi by 2, and this is minus pi by 2, and that's how it works. So the reason there's a minus is because if it's down here, then you'd use minus r cos theta, and same for x equals r cos theta because it's still positive, but the y value would be minus r sine theta. If we have it up here, it would be minus r cos theta, and y is r sine theta because the y is positive and the x is negative. And if it's down here, well, both x and y are negative, so x is minus r cos theta and y is minus r sine theta. So yeah, that's polar coordinates. There's obviously more stuff you can do with polar coordinates. You could sketch polar graphs. Polar coordinate graphs actually look really cool. I'll do them in another video. But for now, I just want to leave you with one more thing. With the polar axes, you'd probably be thinking, okay, so it's theta up here and r here, similar to x and y. X is on the horizontal, y is on the vertical. So you'd probably think r and theta, r is on the horizontal and theta is on the vertical. I used to think that, but then I realised it's wrong. Everything is theta. The whole thing is theta from this point, which is 0. So that would be pi by 2. This would be pi. This would be minus pi by 2. And this would be 0. Or 2 pi. Or another way of doing it is, instead of doing the negative, you can do pi by 2 here. Pi, 3 pi by 2, and 2 pi. Because 2 pi is the same as 0. Sine 2 pi is the same as sine 0. So just remember, there is no x and y similar to r and theta, if that makes sense. The value of r is this, and the value of theta is this. So yeah, that's just a brief introduction to polar coordinates. I'm going to make some future videos on this topic, and I hope you enjoyed. So thank you for watching, and remember, maths is the way.